Hello, geometry folks, and welcome to exploring rectangles, rhombuses, and squares. These are all kinds of parallelograms, and they're also quadrilaterals. So we're going to be looking at these special parallelograms today, what properties they have, and what makes them so special. So you need your notes and the figures I gave you in class and a pencil, and we will get started. Let's first talk about a rectangle. A rectangle is a parallelogram, and the reason why we know it's a type of parallelogram is because the opposite sides are equal and parallel. So we can say BC is congruent to AD, CD is congruent to BA. We can also say BC is parallel to AD, and CD is also parallel to BA. All right, that is one of the properties of a rectangle. Another property of a rectangle is that all the angles are 90 degrees. Now that's a little different than a parallelogram because a parallelogram is kind of slanted and a rectangle doesn't have any slants. So because a rectangle doesn't have any slants and it has 90-degree angles, it makes it just a little bit special type of a parallelogram. All right, another property is that the diagonals are of equal length. So AC is congruent to BD. Another thing that we know about a rectangle is that the diagonals are bisected. So they all meet at point E, and we can say that because they're all bisected and they are of equal length, EC is congruent to AE, which is congruent to BE, which is also congruent to ED. Now this happens because it's not a slanted parallelogram. So it does have some properties of the parallelogram, which makes it a type of parallelogram, but it does have other different qualities. Because it's not slanted, it has that 90-degree angle, and then the diagonals are bisected. So we can say AE is congruent to EC, which is congruent to BE, which is congruent to ED. All right, that's a rectangle. Let's go ahead and take a look at a rhombus. And a rhombus is also a parallelogram, but it's a parallelogram where all the sides are congruent. So in our other parallelogram that we talked about yesterday, all the sides were not congruent. So now we have congruent sides. Okay? And the opposite angles are congruent. So we can say angle 5, 6 is congruent to 3, 4 added together. So angle A is congruent to angle C. Okay. Angle B is congruent to angle D. Okay. We can say that consecutive angles are supplementary. That's just like a parallelogram. These two angles would equal 180. The angles, remember, not the whole side, but the angles. So angle A plus angle D would equal 180. The diagonals are bisected, okay? So that means from point E, we bisect AC and BD. But notice, because it's slanted, these aren't. Okay, so AE is congruent to EC, but BE won't be congruent to EC. So not all the diagonals are congruent, just the ones that get bisected. So BD is bisected and AC is bisected, but they're not all the same like they are in a rectangle because they have that slant. So that's similar to a parallelogram. The diagonals are intersecting to make a 90-degree angle. So all these diagonals intersect to make 90-degree angles all the way around. So there's a 90 here, 90, 90, 90, okay? And the last property of a rhombus is the diagonals bisect opposite angles. So if I were to talk about them bisecting opposite angles, we could go ahead and say even further that, let me pick another color here, 5 and 6 are the same as 3 and 4, and 3 and 4 are equal. So 5 and 6 are equal, and 3 and 4 are equal. So we could say the measure of angle 5 is equal to the measure of angle 6, which is equal to the measure of angle 3, which is equal to the measure of angle 4. Well, we could also do that for 1 and 2 and 7 and 8, because angle B is congruent to angle D. We bisect that angle. 1 is congruent to 2, and 7 is congruent to 8, but 1 is congruent to 7, and 2 is congruent to 8. They're all congruent to each other, so we can say that same thing. The measure of angle 1 is equal to the measure of angle 2, which is equal to the measure of angle 7, which is equal to the measure of angle 8. So now we've talked about rhombuses. So now that we've taken a look at the rhombus, we're going to go ahead and look at the next figure. So we have a rectangle and a rhombus getting married. Yay! They get married. Congratulations. And what do they have but a square? They welcome a special baby, the square. Now, why is the square so special? Well, the square is so special that it has all the properties of all the shapes we've talked about. Every single property we talked about with a rhombus and a rectangle, the square has. So we have lots more properties to write down for the square. So make sure you're taking good notes. Okay, square. All the sides are congruent or equal. So we have BC, CD, AD, BA. They're all congruent. That's what that means. The opposite sides are parallel. Okay, so parallel, parallel. CD is parallel to BA. Okay. The angles are all 90 degrees. So we have all 90-degree angles here. All the angles are the same because if they're 90, they're all the same. Okay. The opposite, they're congruent. Consecutives are congruent and opposites are congruent. We also know that the consecutive angles add up to be 180. Well, if they're all 90, 90 plus 90 is 180. So it doesn't matter which 90 angle you take plus another 90, you're going to get 180 degrees. The diagonals are equal in length. Okay, so we know that AC is congruent to BD. All right. And because we know that, and notice that like it's not like a rhombus here, it's like a square, or like the rectangle, and it's sitting not slanted, and they are equal in length, that point E will bisect them all equally. So all these parts will be equal. Okay? Diagonals are intersecting to make 90 degrees. So these are all making 90 degrees here. All right. And the diagonals bisect opposite angles. So BD is going to bisect this 90, which means this is going to be 45 degrees, 45 degrees, 45 degrees, 45 degrees. Same with C. Each one is 45. Okay. So every property from the rectangle and rhombus and parallelogram, we get all those properties coming together to make us a square. So let's go ahead and try one. So if I tell you this is a square, what is the length of the sides? Okay, the length of the sides around the outside. Well, let's go ahead and take this triangle right here. Okay, let's talk about that. So I'm looking for this side. Well, what do we know about a square? All sides are equal. Okay, so every single side is x because we don't know what they are. If we take this triangle and we look at it and we look at all the properties of a square, we should know that this makes a 90-degree angle, which makes that the hypotenuse. The other property that we learned about a square is that all the diagonals are bisected. So if this is 7, this is 7, this is 7, and that is 7. What else did we learn about a square? Well, the 90 degrees are bisected as well, and I have a 45 and a 45. So guess what? I have a 45, 45, 90 triangle. And if the sides are 7, what's the hypotenuse? Well, the hypotenuse is equal to side, or leg, we can call it the leg, times the square root of 2. So 7 square roots of 2 is the hypotenuse. Now, if the hypotenuse is 7 square roots of 2, then every single part, every single side is going to be 7 square roots of 2. Well, we should know that the area of a square is base times height, or side squared. Okay, so we can take 7 square roots of 2 times 7 square roots of 2, or 7 square roots of 2 squared, and we would get 7 squared is 49, square root of 2 squared is 2. 49 times 2 would be 98 centimeters squared. Okay, so that's it for today. Thank you for taking good notes, and we will see you tomorrow.